In this lesson, we are proving lines are parallel. Our essential question: how can you prove that two lines are parallel? Postulate 16, corresponding angle converse. If two lines are cut by a transversal so that corresponding angles are congruent, then the lines are parallel. Basically what they're saying is if you have two angles that are congruent and they are in the same location when you draw that box, as angle 1 and angle 6 are, then lines J and K are parallel. Theorem 3.8, alternate interior angles converse. If two lines are cut by a transversal so that the alternate interior angles are congruent, then the lines are parallel. Again, working backwards, this time it's saying if you have two angles that are alternate interior angles as 3 and 1 are, and their measures are the same, then the lines J and K are congruent. Theorem 3.9, consecutive interior angles converse. If two lines are cut by a transversal so that consecutive interior angles are supplementary, then the lines are parallel. In this case, we notice that angle 1 and angle 2 are on the same side of the transversal and that they are inside the parallel lines, and we know that the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees, then we can say that line J is parallel to line K. Theorem 3.10, alternate exterior angles converse. If two angles are cut by a transversal so that alternate exterior angles are congruent, then the lines are parallel. If I draw my letter Z, and I notice that the angles outside my letter Z that are on opposite sides of the transversal and outside the parallel lines, if the measure of angle 4 and the measure of angle 5 are equal, then they are congruent, and so we can say that the line J is parallel to line K. Example 1. Prove the alternate exterior angles converse. We are given that angle 1 is congruent to angle 2. We need to prove that line M is parallel to line N. We always start with what we are given, and we are given that angle 1 is congruent to angle 2. Because I know that angle 2 is a vertical angle to angle 3, then I know that angle 2 is congruent to angle 3 using the vertical angles theorem. Looking back at step 1 and 2, I notice that angle 2 is common for both step 1 and step 2, so I can get rid of this middle guy, and using the transitive property of congruence, I can say that angle 1 is congruent to angle 3. I notice over here in my picture, if I drew a box around angle 1 and 3, I notice that angle 1 and angle 3 are on the same location inside the box, so they are corresponding angles, and I also know that their measures are the same, so using the corresponding angles converse, I can prove that line M is parallel to line N. Example number 2, applying the alternate interior angles converse. Find the value of x that makes line P parallel to line Q. The first thing I need to do when I'm trying to solve for x is figure out what is the relationship between these two quantities. If I draw my letter Z, I notice that 9x minus 2 degrees and 6x plus 34 degrees are both inside the letter Z, or you could say that they're on different sides of the transversals and inside the parallel line. So I know that 6x plus 34 and 9x minus 2 are alternate interior angles, and I can say that lines P and Q will be parallel if the marked angles are congruent. If they are congruent, then we can set these two angles equal to each other. So we can write 6x plus 34 is equal to 9x minus 2. To solve for x, we're going to first add 2 on both sides, and we get that 6x plus 36 is equal to 9x. Subtract 6x on both sides, and we get that 36 is equal to 3x. Divide by 3 on both sides, and 36 divided by 3 is 12, so x is equal to 12. Alright, checkpoint problems number 1 and 2 are yours. For each of these problems, find the value of x that makes line P parallel to line Q. Alright, that's it from me. I'll see you all soon.